And welcome to Lecture 2, Chapter 1 of Python Programming with me, Mace. So, in the last video, we talked about getting to know your Python environment, essentially, and print and input functions, as well as variables, which are going to be the subject of today's video. So, today we're going to talk about the primitive data types and variables. It may sound complex, but it isn't once you get to know. So, let's get into it. As you can see in the here, a equals 1. So in the last video, we actually talked about how a is stored into the computer's memory with a value of 1. The computer knows that a is 1. So that's pretty easy to remember, really, isn't it? But if we go down to the next line, f equals a. This means f has the value of a. F doesn't actually equal a. We're going to get down to that later. But f doesn't actually equal a. If we did print f, it wouldn't print a. It would print the value of a. So if we actually got rid of a, and we ran this, well, we got to save it. And if we save it, and we run it, you can see that we get an error. A is not defined. So a isn't actually defined. F equals a, the computer's like, okay, the value of a is going to be assigned to f. But there is no a, so the computer's like, where's a? So if we actually add a equals 1, then f is going to equal 1 as well. So let's test this out. Oh yes, we're also going to add a function afterwards, which we'll talk about in a later chapter. So that's just going to print a and f, instead of repeating the code over and over again. So you can see a equals 1 and f equals 1 in that iteration. As you can see here, a equals 1 and f equals 1 in that one iteration. So, but what if we change the value of a into 3? What if a becomes 3? So f equals the value of a, right? But what if we change it a to 3? Let's see what happens as well. So you can see that a is 3, but f stays as what? 1. So the thing is, a and f aren't actually, they don't have a relationship. F equals the value of a at that current time of assignment, which means f will always be 1, even if we make a that number. F will stay as 1 because at the time of assignment, f was the value of a at that time. So that is why AF is still 1. So that is important to know, but we'll talk about that later in later lectures where it becomes more important. So let's go on to the primitive data types. So what are primitive data types? When we create a variable in Python such as L, we can do this, L equals 1, or we could do this, L equals 1. There is a difference between the two, but how do we actually get the computer to see that difference? How do we get the computer to recognize that there's a difference there? So that's where data types come in. As you can see here, wait a second. As you can see here, these are all different variables. My int equals 1, my float equals 1.0, my string equals 1 with quotation marks, my character equals h with quotation marks, and my bool equals true. So let's work through these one at a time, starting with my int. So my int is a variable, and it is being assigned as an integer. An integer is a whole number, and we all know that from maths, and it also applies here in coding. So 1 is an integer, and that's what differentiates it from float. What makes these two different is this one is a decimal. Float is a decimal variable, but int is just a whole number. Any whole number. However, float is a decimal. If we make my float equals 1, it's going to be stored as a decimal, 1.0. So my float and my int are different in the way that my float is a decimal and my int is an integer. So this is an integer data type. When we assign these two variables, the computer automatically recognizes them with their data type. So this is automatically recognized as int, and this is automatically recognized as float. And so the computer automatically recognizes this. It's really useful. Next, we move on to string. So string, my string equals 1. So when we print my int and my string, see, let's do that right now, actually. Print my string, my int. Watch this. So as you can see here, they're both 1. It printed my string and my int. So on printing, they look the same, but the computer actually stores this as a letter. The letter 1, if you get that. The computer stores it as a string, and a string is just any character. So we'll get to characters. But a string is literally any letter, anything on your keyboard, really. And it's stored as a sentence, really. So you can do my string 18888, and that would not actually be stored as a number, but the sentence 1888888. So that's what differentiates my string in this case from my int. But it's not really used in this way that much. You can do my string hello world. So now it's the sentence hello world. You can't do my int hello world. And once again, the computer automatically recognizes this as a string, and when we assign it, it will recognize that in that way. So now we get to characters. As I talked about in strings, a string is made up of individual characters: H, E, L, L, O, space, W, O, L, R, L, D. So a character is just one character, anything on your keyboard: H, 1, Q, semicolon, comma, anything really. Wait, that wasn't apostrophe. But like anything really. So it's anything on your keyboard, any character, any one character. And so a character is part of a string, and it's just we'll use it in later chapters, but it isn't the most used data type when we compare it to string, float, and int. And again, this is also auto-assigned as a character. Oh, whoops, I didn't do a comment there. And lastly, we get to my bool. My bool is a Boolean. A Boolean is in your computer's memory is stored as a true or false. So in your computer says, it's true or is it false? So this is used widely. Like if we do something like while my bool and print 1, print, oh wait, 1 isn't actually a variable, is it? We'll just do string 1. We have to print the string of 1. So we haven't taken you through while loops yet, but we'll get to that. So it's looping as long as it's true. So true is a state where everything will keep going. So you can also set my bool to, you guessed it, false. Oh, whoops, equals false. So those are the primitive data types, the simplest of them. And now we're going to be talking about how they use their applications. So let's say we wanted to create a program. Oh, by the way, this is also auto-assigned as bool. So if we wanted to create a program, let's go with our name program from the last one. So A equals, oh no, let's go with a different one. What about item? Wait, item equals input. So this is asking this is printing something out and asking for an answer. Item equals input. What is the cost of your what is the cost of your item? and now let's make a quantity variable. All right, quantity equals 10. So you're going to be so now we want to find the cost. We want to find the cost overall. So you want the user to enter the cost of the item and the quantity. So actually, let's do quantity equals input. What is the quantity? So now this program is going to ask the user for the cost and the quantity. So we all know that to find the total cost, we just multiply cost by quantity. So let's actually do that. So total cost equals item times, so this is the times operator, item times quantity. We'll be getting to operators soon as well. So let's try that out. Let's just get rid of these other outputs. And let's try that out. Okay. What is the cost of your item? $12, thanks. What is the quantity? 1. As you can see, you get an error. So it's a type error. Can't multiply sequence by non-int of type string. So that sounds pretty complicated. But what the computer is trying to tell us is this is a string. What you've entered is automatically in input a string. So it's automatically a string. It's not actually a number. It's a string. Oh wait, where did our string go? Okay, my string equals hello. So as you can see with our string, it's a sentence. It's not actually a number. You can't multiply sentences by sentences. Like, who does that? Who can actually multiply a sentence by sentence? It's not possible. That's why we're getting a type error. So how do we fix this? How do we make it so that whatever the user enters, the computer is going to say this is actually a number? That is why we have the primitive data types. So we say int input, and we also do int input here. And as you can see, this is asking the user for an integer input. So now, if you see this here, run module, okay. And let's try this in. What is the cost of your item? $12. What is the quantity? $12. Maybe we'll get 2. And oh wait, we forgot to print the total cost. Print total cost. Run module. Okay. What is the cost? 12. What is the quantity? 4. 48. 4 times 12. So that's why int is primarily used. It is to do that. And you can also make it into a decimal by changing it into float if you want. So you can change this into float. Oh, wait, sorry. As well. And now you can accept decimals as well. So let's do one more run-in of this. And what if we do, what is the cost? We do E. As you can see, could not convert string to float. So you've entered a string, but the computer's asking for a float. Now you may be wondering, why don't we just, there's also another way to do this. You may be wondering, why don't we just do this? This works as well, you know, and it works individually as well. But the thing is, to do this, it will only work here. This, if we get rid of all of this, in this variable, this is still going to be a string. If a user wants to reuse this, it's still going to be reused as a string. That's why we always identify it as a float or an int here, instead of identifying it here. That said, we can actually move this down, as you can see, and we can create a variable like this, a equals float 1.1. So that wraps it up for today's video, and we've just taken you through the primitive data types and variables extension. In future videos, we're going to be talking about how we can do operators and more complex programs with this. Bye.